Welcome to my refining channel, everyone. Today we need to move some metal, and what I've got here is 14K gold. We're going to weigh this up in a big melt dish here. We've got 213.6 grams. That's 14K. 213.6. Now we're going to calculate how much 10K gold we got here. Got 138.3 grams of 10K. 38.3 grams of 10K. Let's do the same with the 18K. We're going to add it right into the 10K. That's 28.7 grams of 18K. Here we go. I've multiplied the weight of each carat times its constant. Came up with these numbers, the amount of sterling we need to inquart the gold, total of 415 or 412.5. Down here I've got 416 to inquart this gold. That's close enough, so that's what we're going to use. 416 grams of sterling silver to inquart our gold. Now we're going to melt the gold in this melt dish.
Some folks like to use the term smelting to describe what I'm doing here. This is not smelting. This is melting the metals. Smelting is the process of rendering metals from ore. It's a mining process, and I've never done any mining. It's important to use proper terminology, I believe.
Now we're going to add the 10K material in here now, carefully. Turn the torch back on. That was the 10K and the 18K.
I'm melting the carat scrap by itself in that small melt dish because after I add the 416 grams of sterling silver, I'm going to have nearly 2 pounds of metal in that small melt dish.
Here's our 416 grams of silver down here. Now what we'll do, we'll take this one out of the way. And what we'll do now is start adding the silver into the molten carat gold. Here we go. This is a fairly large charge of metal here. I've been stirring it for about 2 or 3 minutes, and now we're going to pour it into the water and form our granules. Here we go. Here is our inquarted gold. I'm going to go dump off the tap water now and transfer this into a large 4-liter beaker. Here's the inquarted gold down in the bottom of our container here. I'm going to pour it, transfer it into this 4-liter beaker down here now. As usual, we'll rinse the tap water off with some distilled water so we don't form any silver chloride when we add the nitric to this. I'm going to charge this funnel with some concentrated nitric acid. And what we'll do is we'll do a slow acid drip down into our reaction beaker. That's about 450 milliliters of nitric. And now what we're going to do is put this in the fume hood carefully. All right, what we'll do now is add some distilled water to the beaker. I'm going to put in about, fill it up to about the 1 liter level, I guess, with distilled water. Now we'll turn the heat on. I'm going to give it some fairly aggressive heat here, medium high. I'm going to add just about 100 milliliters of nitric just to get this started. All right, let's put the lid on this thing. And if you look up here, what I'll do is start some of the nitric dripping down into our beaker down here. There it goes. We'll just trickle that acid in slowly until we got a nice smooth reaction going in there.
This is about 2 hours of footage condensed down to just a few seconds. And what we're doing here is using nitric acid to pull all of the silver and other base metals that are in the karat gold out of the gold and put that material in solution. When we get done with this, we'll have pure gold left in the beaker. And we have to add the silver to it in order for this reaction to take place. If we tried this reaction with the karat gold, it wouldn't work.
The solution has been on boiling now for about 3 hours. And what I'm going to do now is I've got a jar here full of sterling silver, and I'm going to pour off this solution into this silver jar over here on my right, so that any excess nitric that's in this solution will be consumed by this silver that's in this jar. Here we go. I'm going to pour it off into the silver jar. This solution is going to be full of silver, and I want to get it rinsed off of our gold in there so that we can put some more nitric in here and continue with these hot dilute nitric acid boils. I'm going to add some distilled water and then some more nitric acid, and continue to try to get all the silver and base metals out of our gold.
If you notice here, the solution is turning green. That's an indication that we have platinum group metals in that solution. Platinum group metals will be yellow. The copper from the sterling will be blue. Blue and yellow make green.
It's taken 7 hours and about 2 liters of nitric acid to get all of the silver and base metals out of our gold. What I'm going to do now is just turn the heat off, and we'll let this cool down. We'll go from there.
If you take a look at the solution here, you'll notice that it still has a little bit of color to it. That's an indication that we probably still have some base metals, platinum group metals, and possibly some silver still in the gold. Here's a look at the pure gold. All the silver, base metals, and platinum group metals have been removed with the nitric boils. That gold in there right now is very close to 3/9 fine. But what we're going to do is add some more distilled water and some more nitric acid and do one more nitric acid boil, the longer we spend here boiling in nitric acid, the fewer problems we'll have later on when we go to dissolve the gold in aqua regia.
Boiling now for about an hour and a half. What we're going to do is pour off this nitric boil now. Still got just a little tint of green in there, but I think we're going to be good here. This is as far as we're going to be able to go with the nitric acid boils. Now what we'll do is set it back on the heat, and I'm going to add a little bit of distilled water to this now, and we'll boil it in some distilled water. The water is just now starting to boil. What I'm going to do is pour the water rinse off here into my silver jar. I'm going to add some hydrochloric acid to this. This is about 6 troy ounces of pure gold in here, so I'm going to add about I will fill it up to about the 500 milliliter level to start it off. I'm going to measure out about, let's see, 6 troy ounces. Let's go with about 75 milliliters of nitric acid. We're going to pour that right on into our reaction here. Here it goes. 75 milliliters of nitric acid. Shouldn't be too hot yet because I just put it on the heat. So I should be able to just add this right on in without worrying about it boiling over.
Here I'm going to add about 1.5 milliliters of concentrated sulfuric acid. This will combine with any lead that may be present, forming lead sulfate, and we can 100% filter it out.
I've just added a few drops of nitric in there. No reaction hardly. I think we've got everything dissolved. I'm going to turn the heat off now and let this cool down. The solution is cooled off to ambient. And now what I'm going to do is we're going to add some ice. To cool the solution off, adding ice promotes filtering. A cool solution or a cold solution filters better than a hot solution. Plus this will dilute the solution and cause any silver chloride that may be in solution to come crashing out, and then we can filter it out. Cooled down now. What we're going to do is filter this solution out. We've got it pulled through the filter. Now what I'm going to do is here's what's filtered out of the solution. I think what we're going to do is we're going to filter it one more time. I'm going to save this filter paper and put it in my paper storage. I've installed a clean filter. Now we're going to filter our solution one more time. This second filtering should help. As you can see in the bottom of the funnel down there, the filter paper has got some black solids that have accumulated on it. Not quite sure what's in here, but every time I go to rinse out the filter, I get some precipitate forming and it goes down into the solution. So what I'm going to do is I'm going to set this solution off to the side, and I'm going to rinse the filter into this separate flask so we don't get that trash down into our main solution here. I'm going to set this off to the side now, get it out of the way. There's what's in the filter. I'll put this in the stock pot. Here is our chloroauric acid solution, gold dissolved in aqua regia. What we're going to do now, it's highly likely that we're going to have some platinum group metals in the chloroauric acid solution. I've got the stir bar running. We're going to add some heat now, and I'm adding ferrous sulfate, also known as iron sulfate, also known as copperas. I'm going to start adding it to this distilled water now to make a solution of ferrous sulfate that we'll use to precipitate the gold. Ferrous sulfate is soluble in water, and so we want to make a nice saturated solution. We're going to be precipitating about 6 troy ounces of pure gold. I've added about half this bottle of ferrous sulfate. So now what we're going to do is I'm going to add hydrochloric acid to turn the solution green. There it goes. That's what we want to see right there. A nice green solution. I've got a funnel with a filter paper set up here. Now what we're going to do is got a big beaker with a stir bar down here. Get the shot right here. Now I'll pour the coppers through this filter up here. The coppers has to be filtered because it does have junk in it that could contaminate our gold. So we want to filter the copper solution before we add it to our gold. This has been dripping in here now for about 2 hours. You can see the funnel up there is still full. It's just coming down drips at a time. And if you look, I've still got a ton of gold in solution. What I did is I filtered some of the ferrous sulfate with a vacuum filter. We're just going to go ahead and add this in now slowly and see if we can speed this precipitation up by adding some filtered ferrous sulfate solution directly to the beaker. I've used every last bit of the ferrous sulfate that I had, and if you look down here, the gold is coming out of solution. This is my PDF copy of Hoke's book, and I didn't consult this before I started. It says here we need a pound, 1 pound of copperas for each 50 pennyweight of gold. 20 pennyweight is 1 ounce, and I've got 6 ounces of gold in there. This is the last little bit of copperas that I have in my on my shelf. If you look here, Stannis test on the remaining solution, and we still have gold in solution. I misjudged the amount of coppers that I'll need. I thought it was only going to be a few ounces of coppers for each troy ounce of gold. So now what we're going to do is we're going to try to filter this copper solution out and we're going to add it right into our beaker and see if we get the rest of the gold to come down. If it don't, I'm going to have to go on a scavenger hunt at Ace Hardware and see if I can find some coppers on the shelf. Here's our filtered copperas solution. I'm going to pour it right on in. I don't know if all this is going to fit in there or not, but we're going to pour this right in and try to get the rest of this gold to drop out of this solution. It's been about 20 minutes since I added the last of my ferrous sulfate. Went in and had a cup of coffee with Miss Sweet Tips. Let's see what we got. Oh, hallelujah, hallelujah. All of the gold has come down now. I was going to have to order some more copperas because I checked locally and there's nothing available locally. It was going to take 4 days to get it in. So I'll try not to make that mistake ever again. Copperas is a good precipitant to use. It separates the metals very well, but as you can see, it produces lots of waste, and so that's the reason I kind of shy away from using it. It's much easier just to throw some SMB in here and precipitate the gold. On the other hand, if there's any platinum group metals in here, which is highly likely, copperas will precipitate only the gold. It will leave the platinum group metals in our solution. And I've got over a gallon of waste here that will have to be gotten off the gold before we can proceed. Pour it into my waste container now. Here's a look at the gold now that we've got all the waste poured off. Now it's just a matter of rinsing all the iron solution off this gold now, and then we'll proceed from there. Rinse it off with some hydrochloric acid until we get all the iron rinsed off of there. It's highly unusual. Look at that. Formed strips of gold in there as it precipitated out. Very unusual. Pour the rinse off in here. A little bit of the gold might go with it. That's okay. We can recover the gold out of this container later on. I'm going to pour in a little bit of hydrochloric acid, and we're going to do a hydrochloric acid boil. We'll let this come to a boil, and then we'll pour off the waste into my temporary waste container, and then we'll do another hydrochloric acid boil until we've got all of the iron rinsed off of this solution. I've got some ammonium thiocyanate here, and what I'm going to do is reach up into our solution, get a little bit of the solution in a pipette. I'm going to put it in a cavity here. Now I'm going to grab a few crystals of this, add it to this spot plate cavity, and if we've got iron in solution, it'll turn bright red, just like that. So what we'll do is just continue to rinse with hydrochloric acid until we've got all of the iron rinsed off of our gold. Just keep going just like this until I get all the iron rinsed off of here. I've had about 10 or 12 rinses with this hydrochloric. I'm going to draw a little bit more up into a cavity in the spot plate. I'm going to check it with some ammonium thiocyanate, and if all our iron is gone, we should get no reaction here now. As you can see, we got zero reaction in there. I've got all the iron rinsed off. We're going to pour this this is water. We'll pour this off now. You can see it's crystal clear. No traces of any color. Put it up on the heat. We're going to add about up to about the 750 milliliter level or so with hydrochloric acid. I'm going to add some sulfuric acid here. We're going to dissolve this a second time. Shouldn't be any lead in here, but I always add sulfuric acid anyway. I'm going to measure out 50 milliliters of nitric acid. And we'll pour that. I'm going to start off by adding about half of this right into the gold. I'm going to start dissolving the gold a second time here. That's taken about 2 hours, but I finally got everything to go into solution here. Nice clear solution. Everything's dissolved. I'm going to take it down off the heat, let it cool down. I've got our solution iced down real good now. What I'm going to do is pour it through the filter. I've got my gas generator set up here in the back. I'm going to bring this up front. Put the delivery tube down into this beaker. Now we're going to take this funnel out of the way. And there's still some trash in here. If you look down in there, I filtered some black colored material out of there. So we'll take that out of the way. Now I'll add the filtered solution to our beaker here. We've got the solution in our beaker. Back in the back, I've got a gas generator. And what I'm going to try to do, I've got 2 cameras running. I got to work around these cameras. What I'm going to do is reach back here and start an acid flow down into a bottle that's got some sodium metabisulfite slurry in it. And I'm adding sulfuric acid to that. And what that will do is that will generate some SO2 gas. And what that'll do is precipitate our gold out. Oh gosh, I just want a little bit going in at a time, not too much. Alright, that should do it for us. We're going to bubble SO2 gas through our beaker, through our gold solution, and precipitate out the pure gold with SO2 gas. Oh, there it goes. This is real time. I'm not time-lapsing this. Forgot to check with Stannis. Let's do that right quick while we still got some gold in solution. I can tell it's still purple. Purple. It's still orange. So I'm going to get a little of our solution on a piece of filter paper here. And we're going to check this now with some stannous chloride just to verify that we've got gold in solution. There you can see that black stain tells us we've got gold in solution. Now this is quite a bit more gold than the last time I did this experiment. This is 6 troy ounces. Last time I did this, we only had 1 ounce in solution. So let's see what happens here. If you look down here, the gold is starting to accumulate down on the bottom. It's pretty neat looking. I'm going to try adding a little bit of distilled water here. This solution, it does not like to precipitate out of a concentrated solution. I remember reading that, so I'm just going to add some distilled water and dilute it. The solution is becoming very pale looking now. It looks like the gold is completely precipitating out of that solution with the SO2 gas. Well, something's happening there. Just turned dark all of a sudden. I think it's getting saturated with the gas. Got a little heat going on in there. It's hot. I think we may have got everything just about precipitated out completely now. Give you a little tour of the gas generator. That's SMB in the flask. I had a clip on it. You can see the green clip laying back there. It broke. And above that, I've got a addition funnel that's got an equalizing tube on it. And we're just slowly dripping sulfuric acid down into that SMB, and then the tube, the discharge from the side arm there goes to this to the top of this flask. It's full of sulfuric acid, and we're bubbling the SO2 gas through the sulfuric acid to cool it and clean it. And then the output of that bubbling flask is going to our delivery tube here down into our reaction beaker. Oh yeah, look at that. It's cleared up nicely now. I think we've got just about everything precipitated out now. All right, we're done here. I'm going to turn the acid flow off back here to the gas generator. Once you start this gas generator, there's no stopping it. You can't turn the gas on and off. Let's get a stannous test on this now. Make sure we got all the gold precipitated out. And there you can see we have no gold left in our solution. Well, that's 6 troy ounces of gold. The gold caked up on the delivery tube It's built up on the sides of the beaker. That was kind of a neat reaction. I enjoyed that one. All this work that I put into this has been 4 days worth of work. I guess it was worth it to see that precipitation. I'm going to reach in here and get the delivery tube. Look at that gold caked up on there. Just slid right off. How about that? Nice. We'll get the delivery tube out of here. Set it off to the side. Thing's still cranking out SO2 gas, which is highly toxic. We're going to get our waste solution poured off of here now. It's completely colorless like water. The gold looks very, very good. Let's try to get some of this gold down into this melt dish now. Boy, oh boy. It comes off in chunks here. Got just about all of the gold in this melt dish now, unbelievably. There's just a few crumbs left in the bottom. I'm not gonna try to get every single bit. Now what we'll do, let's move this over to the melt table now. And we'll get this melt started. Here's our finished bar of pure gold. Looks delicious. Came out real nice. I'm not too sure if I like the SO2 gas precipitation. It was messy. It was dangerous. That gas is very corrosive. Okay, let's see what we got here for weight. 201.9 grams. That's 6.49, say 6.5 troy ounces, and a little bit of the gold did come out of the melt dish out there. I'll gather that up later on, and we'll put that in with the stock pot and recover it later. So, all right, this will conclude the video. Thank you for watching.